All right, so my paper is, of course, about analytical procedures, but this talks a little bit, and I think it's a little bit related to what we're talking about. It's the case of using disaggregate multilocation data, if that makes a difference, basically. Instead of using aggregate data, if we can do the testing in smaller parts first. All right, so this paper uses a case study approach to investigate whether disaggregate individual location data in a large multi-location company, that's where the case study was done, improves the effectiveness of analytical procedures. So first, just a little background about what analytical procedures are, and let's see, my screen is not changing. Here it is. Can you see, because in my screen, I see a part of the Zoom. I don't know if I can minimize that. Okay, I think that's better now. So analytical procedures are basically evaluations of financial information made by a study of possible relationships among both financial and non-financial data. The auditing standards require auditors to use analytical procedures both at the planning phase and at the completion phase of the audit. Those are must. You have to do them, you have to document them, you have to show that you have used them. However, auditors do use analytical procedures, often in the field work as substantive tests, because they're less costly than tests of details, especially if we're talking about big companies that looking at every single detail is not as efficient. So a lot of analytical procedures are performed at that stage too. And there are 4 steps in the analytical procedures. I just quickly explain them so that this paper makes sense. The first is to develop an expectation about the relationship you want to test. And it's based on, again, what you think should be some of the relationships between the balances you're studying. Then you have to set a threshold of what you're willing to accept as a deviation from the expectation. And once you've done that, then you perform your test. And if there are any deviations that are larger than your threshold, then you go and investigate further, meaning that you perform more tests, you're talking to people via interviews, you're looking at more invoices and all that. So and until you explain away your difference and you feel comfortable about this. And if not, of course, you have to propose some adjustments. Okay, so why is this an important topic to be studied by the researchers? Well, because, and again, as we heard in the previous paper, the effectiveness of analytical procedures depends on the accuracy and precision of the auditor's account balance expectation. So if your expectation is not that precise, then no matter how well you tested, how good your calculations are, then your analytical procedures are not going to be effective anyway. So, and there's some prior literature here, some older studies. I mean, this is an old paper anyway, but I think it was in the 90s, but the prior studies were even older. Kinney and Collins in the 70s did some line of business disclosure studies that showed that basically line of business analytics were better at predicting the level of earnings. And then there's some studies that were done using geographic segments, which again showed that those were better at predicting the forecast than using consolidated data. In other words, the conclusion of the prior literature was that when disaggregate data are available, corporate earnings can be more accurately predicted by first predicted segment earnings separately and then aggregating the individual predictions than by looking at the earnings on a consolidated level.
Can I just say two things here, Andrea? First, all these not necessarily baddies, but this is Bill Kinney. He was like the leader in audit research until he retired about 3-4 years ago. And this is a very classic piece of work. Second, our paper contained equations. also looks at aggregation versus disaggregation. I think there we basically find that what Kinney suggested here is accurate, but sometimes if you go at like daily information, maybe you lose the forest for the trees.
Oh, yeah. And here, basically, the possible explanation to why at that level disaggregate data was more useful. They pointed out to heterogeneity across the disaggregated inputs. They felt that the diverse nature of the company's operations could be better portrayed if we looked at different lines of businesses or different geographic segments. So those kind of studies could better capture that diversity. So that's why they're better predicting. Now, sorry, did you have something to say?
I'm good.
Oh, okay, because I heard somebody. So the question here is that, is the disaggregated approach superior in analytical procedures for a single company with multiple location operating units in the same line of business? And that's what this paper tried to explore. Because the prior studies looked at heterogeneous type of operations mostly. So here we do have multiple locations, but the business is in the same line. So the authors hypothesized that the company-wide account balance expectations developed from disaggregate individual location models give more accurate and more precise expectations than company-wide account balance expectations derived from aggregate company-wide models. Okay. So we'll talk a little bit about the methodology in terms of the data that they use, the types of empirical tests, and the model estimation. And it's not a very long paper, but here's a little bit in the background. So they used a large US-based multi-location service company with homogeneous operations, a single line of business. In total, they took 72 monthly observations for 30 operating unit locations. And their collection started from the beginning of the fiscal year 89 until the end of 94. Those locations that they tested provided similar services, which meant that we have homogeneity in nature. But of course, we don't have homogeneity in geographical distribution because those locations were across the country. The company also employed an active, well-trained internal audit staff and was audited by a Big Five public accounting firm, trying to bring a little bit more validity into those measurements. And these locations also monitored closely by upper management and the internal audit department through an extensive monthly actual to budget review process. So the authors are confident with the data that they collected. So what did their empirical test look like? They basically based it on the examination of two models that are commonly examined in prior analytical procedure studies, and they're similar to what auditors do in analytical procedures. The first model is a distributed lag regression model that included two independent variables, and we're going to look at it in a little bit in the next screen. So those independent variables were the previous month's balance, and the other one was 12 months ago balance, the account being examined. The other model was a multiple regression model where the independent variables represent two non-financial operating measures. So the first one was a little bit more traditional of what used to be used in analytical procedures. The second one is more to what the profession, I guess, more leaning towards using non-financial operating measures. In this example, they use the pounds, which is the number of pounds serviced at the location, and days, which is the number of working days during the month. Okay. Also, it's important to say that the models used to develop 32 separate unique account balance expectations. Okay, and those were 30 location-specific account balance expectations, which were computed using location-specific data only. And then the other two were company-level. One was company-level account balance computed by summing up the location-specific account expectations, and the other one was a company-level account balance expectation was computed using company-level data only. So that's what their test looked like. And we can see here in figure 1, which might look a little bit different than the figure 1 in your paper because I erased the second part because it's not relevant to this part of the testing. So in case you're wondering, that's what's going on here. So panel A is the models without the pure data, which we'll talk about as the second type of testing. And this is what the regressions look like. This is the first model that we talked about, which is the distributed lag regression. And we have here, and if you look at the bottom here, those are the different types of tests that they perform. So it's the same model, but they use it to predict different types of balances, right? And this is how they studied it. In the paper, they only have a result about their revenues because the other tests had similar kind of results, but they didn't use just one type of to predict one type of balances. They used it to predict more balances. So here's the first model, and here's the second model. Are there any questions so far, or?
I'm good, but I just want to point something out. This time, distributed lag regression was actually a pretty advanced type of technology. Today is not. And the thing I like so much about this paper, oldie but goodie, is that it's very crisp. You know, the issues that he talks were very crisp. The Tom Kidder's paper that we just talked is not so crisp. Okay, it's kind of fuzzy. And I find Bill Kinney a very crisp thinker. And so I think you can learn a lot about auditing and audit research looking at these old papers by Bill Kinney because he kind of points out the issues very well and very organized. Andrea, what do you think?
Yes, no, I agree. It was very interesting to read and see and how those models were developed. It made sense. I liked it. All right, so let me go to the next slide. All right, so a model estimation now. So the 24 1-month ahead account balance expectations were estimated. They were generated using the most recent 48 monthly observations preceding the expectation target month. And for each of the final 24 months, the account balance expectations were computed by the 2 different models for each of the 30 individual locations that we talked about before, plus an aggregate company level expectations. So once those were calculated, then they were used to compute the absolute percentage forecast error and the square percentage forecast error. So basically, they used the model to see what the expectations of those balances that they're testing should be. And then they compared it to what the balances were, and then they calculated the errors just to see how good their models were in predicting those balances. And here's what we have our results here. So if we look at the first model, we can see that the mean absolute error is 0.0341 for the disaggregate models, which is about the same as the aggregate model. In fact, it's actually a little bit higher for the disaggregate model in the absolute errors, but it's kind of lower for the median, but it's really not by much. So there's really no basic difference in the first model. The second model, interestingly enough, looks like there is more error in the disaggregate model than there is in the aggregate model. So we compare the numbers here for model number 2. It looks as if the aggregate model was better at predicting in this case, which is a little bit contrary to what the previous research was suggesting and to what their hypothesis was. And we see that in the average error. So to test to see what kind of significance there is, they performed the Wilkinson-Ransom pairwise comparison test, which found really no significant difference that is consistent with their hypothesis when they looked at the errors between the disaggregate model and the aggregate model. But they found that actually model 2, just like we saw above, was better than, the aggregate model for model 2 was better at predicting the balances, which is actually not consistent with the hypothesis. And this is something that we see as well when they looked at the adjusted R squares. We can see that the aggregate models have higher expectations here. So it's a stronger R square, especially for model 2 here. Questions here?
Yeah, that's good.
Okay, so then they decided to look at it a little bit different. So they said, okay, let's incorporate some observations of the accounts of interest from the other 29 peer locations within the company to see if we're better able to capture the heterogeneity. This is a Greek word, which I pronounce in Greek, but I cannot pronounce in English. Heterogeneity presented in the individual locational levels. Right, so they performed the supplemental test to determine whether the models developed at the individual locations can be improved, and find that the disaggregate model would be better at predicting the balances than the aggregate. So they did exactly the same thing as before, but with the difference now that they incorporated to their model observations, peer observations that they call them, from the remaining 29 locations, right? So we have 30 locations. So for each one of the locations, we add information from the other 29 locations. And they did that to both models 1 and 2, and those are our models 3 and 4 now. Right, and we'll see that as a comparison now. So this is what we looked at before, and this is the model as it changes now with the other locations all the way up to location 30, the other 29 locations. Right. So what they're finding here is interesting now. Now we're looking at, they're actually able to see that the disaggregated models now have become better at predicting the balances. If we look at the average error here, you can see that the disaggregated models have much better, much lower errors than the aggregate models. The difference is a lot larger. Somebody's speaking? Yeah, sure.
You see the previous slide about the models?
Yeah.
I'm good. Thank you.
You're welcome. Here we go. Right, so now, and also as illustrated in panel B in table 2 here, we can see that every pair works comparison between the disaggregate peer data model and the aggregate company-wide model account expectation. Right, so we can see here too. So models M3 and 4 are better than M1, M3 and 4 are better than M2. Okay. And this is consistent with their hypothesis. And this is also reflected in the adjusted R square. The mean for model 3 is much higher than in the disaggregated model than it is in the aggregate model. And although for model 4, there's a little bit of a difference in the adjusted R square, predicting that the aggregate model was a little bit better at predicting the data, they're still both very high. So that's a very good fitted model.
I think I have a comment here. So I think maybe there's an issue of the overfitting problem here, because now obviously they added other variables, and also the mean error is actually, and the error and the R square actually are not good proxies for predictive power. But that's, but I think at that time people just think that this is good enough. I just want to add a comment here that the explanatory power, which is the R square, cannot be taken equivalent as the predictive power, which is, they are different terms. So I think most of the research talking about predictability is confusing the two terms. But yeah, this is just a side note. But this paper is good by itself at that time.
Thank you. All right. So, and what did they conclude for that is that when the disaggregate models do not include observations from other locations within the company, then the disaggregate models do not result in more accurate or more precise expectations of the company-wide account balances than expectations based on aggregate data only. And as we saw later with the second a round of tests that they've done, when the disaggregate models include account observations from other peer locations in the company, then we have more consistent, more accurate predictions than we would have had with the aggregate approach. Okay, and what that implies for the auditors is that when they're generating expectations of company-wide balances, disaggregate peer location models will provide account balance calculations that are both more accurate and more precise than company-wide aggregate models. But of course, that comes with limitations. And a caveat from the authors is that, you know, this paper does not attempt to develop a theory to distinguish which model is most appropriate. Again, the auditors should really think about understanding the client's top-down core business processes before deciding which model is best to be used in their analytical procedures. Also, we need to keep in mind that this was a case study, so it doesn't, it kind of, you know, limits the generalizability of the findings, so we have to be careful we interpret that. And one more thing is that this study does not attempt to measure the level of homogeneity among the locations. And we said that it was the same line of business, but there was no measure of how homogeneous really those locations were. So the effects of varying levels of diversity needs to be addressed by future researchers. And I think that's it.
Okay, I just want to make a comment about Abby's comment on overfitting. I think Bill's problem here, Bill Kinney's problem, with many of with this paper is a problem we face with many of our projects. Is you have what you have. You know, I never heard a PhD student working on a project with me saying that he or she doesn't need more data. And I never heard an MBA project, an MBA class discussing a case, not wanting to fire the managers. That's the two things that I always hear. And the reality here is that you're working with empirical data of one place. That's what they gave you. It's incredibly amazing that Bill got this data from this company, meaning we have data like the weather study data, and you get what you get, and you have to work with that. And so I don't think the overfitting problem here is terribly serious, but that's, I think, the reason for it. Can I hear, Hanshin, do you have a comment?
Yes, actually, I'm also thinking about the overfitting issue. You're right, Professor. This is not a very terrible issue. However, if you do some shrinkage regression before, actually you can select the most predictive variables, and this is also contains some information. For example, in this paper, if you perform the shrinkage regression like the Nassau and Rich, actually you can know which local account is the most predictive to the final total account. This can be the additional information you can get from the data.
Yeah, I think, you're saying that using some regressions as a way to filter, you could get better results, correct?
You can actually filter some useless information, and this is also very important in some cases.
Yes, I think that's a good point. Any other comments?
I think at that moment, because the machine learning method is still not so prevalent, so people use the traditional way. But if we do this analysis today, we would start from feature selection, which is what Hanxin mentioned, right? We select the predictive variables first, and then decide what models can be most predictive. And here, one important note is that in this paper, the authors use in-sample evaluation, meaning the errors that you see is actually from the, they run the regression using the sample, and then they generate the error using the same sample, which is a mistake if we want to do prediction. In prediction, you need to use out of sample to evaluate the predictive power. So that's the key difference between the econometrics method and machine learning method. So if we do this project today, we can use any other solutions to see what are the variables that are predictive, what are the models that are predictive, and how predictive are they. So that's the comment. Yeah.